This is the second lecture on class 12 maths chapter 2, which is inverse trigonometric function, and in this video I am going to give the complete solution of exercise 2.2. At first I'll solve all the questions on from exercise 2.2, and at the last I'll give all the trigonometric identities used together. So starting with exercise 2.2, question number 1, 2 and 7. These three questions we are going to use these three identities. I'll first solve question number 1. Question number 1 is to prove 3 sine inverse x is sine inverse 3x minus 4x cube. I'll take the right hand side. From the right hand side I'll show that it is equal to right hand side, LHS. So first RHS is sine inverse 3x minus 4x cube. Then this term you can clearly understand, you can see it is matching with this right hand side. Here 3x minus 4x cube, here 3 sin theta minus 4 sin cube theta. So this term, if you compare with this sin 3 theta right hand side, then you see in place of x there is sin theta. So we will take x is equal to sin theta. Then what it will be? X is taken sin theta minus 4 sin x cube, so sin cube theta, and this one you see clearly, this is the right hand side, 3 sin theta minus 4 cube sin cube theta, which is the identity of sin 3 theta. So I can write it, this term is equal to sin 3 theta. Now sin inverse sin is getting cancelled, remaining only 3 theta. Now theta is not there in the question, theta we have just substitute, so theta must be removed, and theta we have taken, see we have taken sin theta is x, so theta will be sin taking to the right side, it will be sin inverse of x. So I can write theta equal to sin inverse of x, and which is the LHS and is the complete proof for the question. So I'm explaining once again. First you will see, you have to know the identities, and the term here, it is matching with which identity? It is matching with, clearly matching with this right hand side. And if we compare, in place of x there is sin theta. So we have taken x is equal to sin theta, and this is the after taking x equal to sin theta, the term, it is the identity of sin 3 theta, and then sin inverse sin cancel, and we clearly got the LHS. Then the second question, second question is, say 3 cos inverse x is cos inverse 4x cube minus 3. So I'll take RHS. RHS is cos inverse 4x cube minus 3x. Now this term, it is matching with which identity? You see here, this term, it is matching with this right hand side of cos 3 theta identity, and in place of x what is there? In place of x cos theta is there, so we'll put x is equal to cos theta, and if we take x equal to cos theta, then it is 4x cube is cos cube theta minus 3 cos theta, and this is the identity, you see, 4 cos cube theta minus 3 cos theta is the identity of cos 3 theta. So we can cancel cos inverse cos, and if you can cancel, then after cancelling remaining only 3 theta, and then theta must be removed. What we have taken? We have taken cos theta for x, then theta will be cos is taken to the right side, so it will be cos inverse of x. So it is 3 cos inverse of x, and which is the LHS. And this is the complete solution for this question. Next, taking the question number 7. Taking question number 7, here this term, it is matching with this tan 3 theta identity, but here a little different from before. We have to put x is equal to a tan theta here. If we put x equal to a tan theta, then what it is? 3a square x is a tan theta minus x is again a tan theta cube, then a cube minus 3a, x is a tan theta square. Now we'll simplify. The question is to simplify. This question is to simplify, not LHS, RHS. Then a cube is common. Remaining 3 tan theta minus a cube taken common, so only remaining 10 cube theta. Here also a cube is common, 1 minus 3 tan square theta. And then a cube is getting cancelled, remaining 10 inverse 3 tan theta minus 10 cube theta by 1 minus 3 tan square theta. And this is the identity, you see the right hand side, which is the identity of tan 3 theta. So this can be written as tan inverse tan 3 theta. Then tan inverse tan cancel, remaining only 3 theta, and then we must remove theta. We have taken, what we have taken? We have taken x is equal to a tan theta. From here, if we find tan theta, it will be x by a, and theta is tan inverse x by a. Then in place of theta, what we can write? Tan inverse x by a, it is shown here. And then this is the simplest form. We can write which is the simplest form. Question number 3 is to simplify and to remove square root. First we will do trigonometric substitution. Trigonometric substitution, x equal to, I will take here tan theta. How we will know that we have to take x equal to tan theta, sin theta, cos theta? It is like this. If square root of 1 plus x square, then you take x is equal to tan theta. The reason is, if you take tan theta, then 1 plus tan square theta is equal to sec square theta, and you will be able to cancel root and the square, and then you will get like this sec theta only. And if we have a square root of 1 minus x square, then you take x is equal to sin theta. Either sin or cos also can be taken, because why taking sin? Because 1 minus sin square, we have the formula of cos square, which we have learned in class 10, and then square and root you can cancel, will remain only cos theta. That means we are able to remove the square root. So remember, when there is plus, we have to take 10, because we have 1 plus tan square. In this case, if you take sin, then 1 plus sin square, there is no formula, so it will be wrong way. And then if it is minus, then we have to take sin theta. The reason is we have 1 minus sin square formula. So in this case plus, so I am taking tan theta, and if I take tan theta, then what it is, say it will be 1 plus tan square theta minus 1 by x is taken tan theta. So it is tan inverse 1 plus tan square is sec square theta minus 1 by tan theta. Square and root getting cancelled. It is remaining sec theta minus 1 by tan theta. Then class 10 we have learned formula sec theta is 1 by cos theta, tan is sin by cos. So I can use this formula. So it is now tan inverse sec theta is 1 by cos theta minus 1 by sin theta by cos theta. Then taking LCM in the numerator cos theta, and I'll get 1 minus cos theta, and denominator remaining same sin theta by cos theta. Then you can cancel this cos theta. Now what is remaining now? Is remaining tan inverse 1 minus cos theta by sin theta. Then trigonometric identities. The identities at the last I'll give all the identities together. Then trigonometric identities, we have 1 minus cos theta, we have 2 sin square theta by 2, and sin theta we can use 2 sin theta by 2 cos theta by 2. So these identities we can use here. Then 1 minus cos theta is 2 sin square theta by 2, and this is 2 sin theta by 2 cos theta by 2. Then getting cancelled, 2 square, sin square and sin also will get cancelled, remaining only sin by cos. And finally it is tan inverse sin by cos will be tan theta by 2. Tan inverse tan cancel, it is only theta by 2, which can be written as half of theta, then theta must be removed. Theta must be removed. You say you have taken, what you have taken? You have taken tan theta for x. So if you remove theta, it will be tan inverse x. So finally 1 by 2 tan inverse of x, and you can say this is the simplest form. The question is to simplify, and what we have got is the simplest form. Question number 4, again tan inverse under square root 1 minus cos by 1 plus cos, and this one will be directly using the identities. We have 1 minus cos theta is 2 sine square theta by 2, 1 plus cos theta, identity is 2 cos square theta by 2. So we can directly use the identities. So 1 minus cos is 2 sine square x by 2, and this is 2 cos square x by 2. So 2 is getting cancelled, and then sine by cos is 10, square is there, so 10 x by 2 square is there, and then square and root will be getting cancelled. Will remain only tan inverse, 10x by 2 is remaining, then tan inverse 10 cancel. What is remaining? Only x by 2, and we can say is the simplest form. This is the simplest form. The next question is question number not 8, it is question number 5 from textbook. It is also to simplify. Now in this term, both numerator and denominator will divide by cos x. Some steps you have to memorize. Both numerator and denominator, every term will divide by cos x. Then what we will get? You see, cos x divided by cos x will be 1. Sin x by cos x is 10x. Cos by cos is again 1. Sin by cos is again 10. And then this term we can write like this. In place of 1 we can write 10 pi by 4, because 10 pi by 4 is 1045, value is 1. So in place of 1 we can write 10 pi by 4 minus 10x remaining same. This 1 I will keep as it is, and here I can write 10 pi by 4 into 10x. It is correct because 10 pi by 4 value is 1. So 1 into 10x is 10x, it is correct. Now why writing like this? Because we have a formula tan of a minus b, which is 10a minus 10b by 1 plus 10a 10b. So this term now it is matching with the right hand side, which is equal to 10 of a minus b. So this can be written now 10 of a minus b. A is pi by 4 minus b is x, and then you can cancel 10 inverse 10. What is remaining? Pi by 4 minus x, and you can say this is the simplest form. It is simplified. The answer we got is the simplest form. Next question number 6, tan inverse x by root over a square minus x square. Here I am going to do trigonometric substitution. I will put x equal to a sin theta. You remember, if we have like this root over 1 minus x square, then we are taking x equal to only sin theta. But if we have a square minus x square, then x is equal to a sin theta. We have to take a there so that a will be taken common, a can be taken common, and then it can be simplified. So here a is there, so I have to take x equal to a sin theta. Then let us see, x equal to a sin theta, and here a square, x is equal to again a sin theta, whole thing square. Then we will simplify. See, a square is now common, will remain 1 minus sin square theta. A square is common, and then a square, 1 minus sin square is cos square. Then you can write like this, a sin theta, and a is having square, cos also is having square, so you can make it a cos theta whole thing square, and then square and root can be cancelled, and it is finally remaining a sin theta by a cos theta. Then a also is getting cancelled, remaining tan inverse sine by cos is tan theta. So that tan inverse tan cancel, remaining theta only, and then we must remove theta. Theta is taken, see, we have taken x is equal to a sine theta, then sine theta is x by a, and theta will be finally sine is taking to the other side, it is sine inverse of x by a. So final answer is theta equal to the conversion I have shown here. Theta is equal to sine inverse of x by a, and this is the simplest form. Next, solving question number 8 is very simple. It is a short question for 1 mark. See, the below known value is given 1 by 2 sine inverse. So first we'll start from the last part, this part. Remember, 1 by 2 we'll write in terms of sine. Since it is sine inverse, so this 1 by 2 will write in terms of sine. Other things will keep as it is. Everything keeping same. Sine inverse 1 by 2 is sine 30 pi by 6. And then sine inverse sine cancel. Remaining 2 cos twice pi by 6. Then this is getting cancelled. You will get like this, twice cos pi by 3. Then cos pi by 3 we know. What is cos pi by 3? Cos 60. Cos 60 value is again 1 by 2. And then this 2 also getting cancelled. Remaining only tan inverse 1. Now this 1 we have to write in terms of 10. Since it is tan inverse, so 1 also will write in terms of 10. And 1 is 10 pi by 4, 1045. Then tan inverse 10 cancel, and the final answer, final result is pi by 4. Now question number 9. To solve this question, we must know first these two identities, sin 2 theta and cos 2 theta, and also we have to know this property. Then we can solve this question. And this term, you see, it is matching with this right hand side, and in place of x we have tan theta. So here we will put x is equal to tan theta, and this second term, it is matching with this right hand side of second identity. Again here in place of x we have tan theta, so put y is equal to tan. Theta we will not take, since already we have taken theta here. We will take, say, phi. Then this will be equal to tan 1 by 2 sine, what we have taken, x we are taking tan theta, so this is 2 tan theta by 1 plus tan square theta, and this is cos inverse 1 minus tan square phi. I have taken phi. Theta we cannot take both. In both the cases we have to take different. So here again tan square phi. Then this is the identity, first identity, it is the identity of sin 2 theta. This term, sine of, here it is, it must be inverse. So this is sin 2 theta and cos inverse of, this is the second identity, it is cos 2 theta. Here it is cos twice phi. Then sin inverse sin cancel, cos inverse cos cancel. What is remaining? It is remaining like this, 2 theta plus twice, yes, correct, 2 theta plus twice phi. Then tan of 1 by 2, 2 common, theta plus phi. 2 is getting cancelled, tan of, now what is theta? You see, we have taken x is equal to, we have taken tan theta. So theta will be tan inverse of x. Theta is tan inverse of x. And what is phi? We have taken y is equal to tan phi. Y is equal to tan phi. So phi will be equal to tan inverse of y. So it is tan inverse of y. Now this is the identity, you see, not identity, this is the property, this property, tan inverse x plus tan inverse y. It is tan inverse of x plus y by 1 minus xy, and tan inverse tan cancel. What is remaining? X plus y by 1 minus xy. This is the solution. complete solution. So for this question you have to know these two identities and also you have to know this property. Question number 12. Tan of sine inverse plus cot inverse. You, without memorizing any formula, any ratio, inverse ratio can be converted into any other. Sine inverse I can convert into cos inverse, tan inverse, cot inverse. Cos inverse can convert into any other. So what I'll do, this sine inverse I'll convert to tan inverse, and cot inverse also I'll convert to tan inverse, so that I can use this property. And how to convert? You say sine inverse, as I said, any ratio can be converted into any other ratio. For this I'll make one triangle. Sin theta is perpendicular by hypotenuse. This is the angle theta, and this is perpendicular base hypotenuse. That is the concept of class 10. And sin theta is equal to perpendicular by hypotenuse. That means here 3, perpendicular is 3, hypotenuse is 5. And Pythagoras theorem you use, you can easily find out this will be 4 by Pythagoras theorem. Then you see sin inverse, it will become now tan inverse. How much? Tan theta is perpendicular by base, so tan inverse 3 by 4. Easily can convert any ratio to any other. For second term you make another triangle. Cot theta is base by perpendicular, so base by perpendicular, base is 3, perpendicular is 2. In this case hypotenuse if you don't find also is okay, because you are going to convert into tan inverse. Tan is perpendicular by base, so it will become 2 by 3. If you need to convert into sine, cos and other ratio, then you need to find out hypotenuse by Pythagoras theorem. Now in this you can apply this tan inverse x plus tan inverse y property. Property is written here. So it will become like this: tan inverse x plus y by 1 minus xy. This is the property I have used. Tan inverse x plus tan inverse y is tan inverse x plus y by 1 minus xy. Now tan inverse tan cancel, and whatever the number remaining, 1 minus 3 by 4 into 2 by 3. This whatever is remaining you can simplify and you can get the answer. So you remember, any ratio can be converted into any other ratio by using this triangle without memorizing any formula. Only you have to know the Pythagoras theorem and the ratio of class 10 ratio. Sin is p by h, cos is b by h. That only the 6 ratio we have to know. Then any inverse ratio we can convert into any other. You say sin inverse converted into tan inverse, sin inverse I can convert it to cos inverse also, sec inverse also. Any ratio we can convert. Then now I'll give all the trigonometric identities together so that you can memorize easily. The trigonometric identities we have used here: sine 2 theta. Sin 2 theta is 2 sin theta cos theta. Cos 2 theta is cos square theta minus sin square theta. Then we have another identity: 1 plus cos 2 theta is 2 cos square theta, 1 minus cos 2 theta is 2 sin square theta. These two identity memorized together. Plus is cos, minus is sin. And then these 4 identities, you see, we can make into new set of identities by replacing 2 theta by theta. If we replace 2 theta by theta, then theta will be replaced by theta by 2. Then these identities will change now. We can write like this: sin theta is equal to 2 sin theta is theta by 2 cos theta by 2. The second identity we can write now: cos theta is equal to cos square theta by 2 minus sin square theta by 2. This identity it will be now 1 plus cos theta is equal to 2 cos square theta by 2. This will be 1 minus cos theta is equal to 2 sin square theta by 2. Now this right side don't memorize, you memorize only this left side, and you see this tricks, this technique, how to make this new set of identities by this substitution. Then we need this identities again: sin 2 theta, cos 2 theta and tan 2 theta. Sin 2 theta in terms of tan I am writing now. Sin 2 theta is 2 tan theta by 1 plus tan square theta. Cos is 1 minus tan square by 1 plus tan square, and sin by cos is 10. So this denominator will get cancelled, 2 tan theta by 1 minus tan square theta. So this is another set of identities which we must know. Then another set, sin 3 theta, cos 3 theta, which we have used here, tan 3 theta. Sin 3 theta is 3 sin theta minus 4 sin cube theta. Cos 3 theta is 4 cos cube theta minus 3 cos theta. And tan 3 theta is 3 tan theta minus tan cube theta by 1 minus 3 tan square. So this is another set of identities. So these are the identities we have used in this exercise, and these identities we even need in miscellaneous exercise. So this is the end of this lecture, and in the next lecture, lecture 3, I'll give the solution of miscellaneous exercise along with extra questions.